Good evening, friends. We have initiated the electrical control circuit. So, it is clear that there are two main circuits, power circuit and control circuit. Control circuit assists to main circuit because high power circuit is fatal if you come to its close vicinity. In control circuit, the power used mainly 110 volt DC or 220 volt DC within safe limit, means safe limit of power and expressed in ampere hour of battery. Other main things is relay. We are using its two types of contacts. One is normally open, another is normally closed. In relay, in de-energized condition, which contact is closed, that is normally closed. And in relay, energized condition, it will open. On the other hand, which contact is open in de-energized condition, that is normally open, and when it is energized the contact is closed. It has two tip contacts and DC positive is given. The normally open contact, the DC positive is not bridged to extend DC positive to other circuit coil, whereas negative is permanently connected to one end of that coil. And when normally open contact is closed after energization of relay, the DC positive extended in that coil and coil is energized, and normally open contacts is vice versa, means when normally open contact is closed, the DC positive extended to energize a coil where negative is permanently connected to one end of the coil. It may be a overcurrent relay, it may be a trip coil, or it may be a closing coil, etc. In control circuit, we are utilizing these two contacts widely. Okay, now I'll show you some movement of these two types of contacts. See how. In the picture, we see a relay with a normally closed contact and a normally open contact, and the relay coil is de-energized condition. So the normally closed contact is closed and one end is of the normally closed contact positive is given. So this positive will be extended with the normally closed contact as it is bridged by the normally closed contact de-energized condition, and another contact is normally open. DC positive is also given here, and when the relay coil will energize, the contact will be bridged and the DC positive will be extended. How? See it. Now, when the relay coil will be energized, the plunger will be pulled by the magnet and normally closed contact will open and normally open contact will close, and DC positive will be extended through this normally open contact. Now we will see the use of this normally closed contact. The DC positive will be extended in the coil. Suppose this is capacitor bank trip coil, cannot capacitor or capacitor tripping device in induction or circuit breaker. If the DC fails in the traction substitution, the relay coil for capacitor tripping device is dropped, and with this normally closed contact, the circuit breaker trip coil energized from this contact and circuit breaker tripped. Because if DC is not there, then it will trip. But where it is getting this DC positive in the normally closed contact, it is from the capacitor. One capacitor is there and its DC positively extended. It stores the power when DC is available, and if it will fail, then this DC will be extended to the trip coil of the circuit breaker. See how. Now we'll see the application of normally open contact. Suppose this is an overcurrent relay. An overcurrent relay is energized, so it will pull the plunger, and this normally open contact will be breached, but the normally closed contact will open, and the circuit breaker will trip. See how. So friends, we are using this normally open contact and normally closed contact to extend DC positive, or to break a circuit, or to make a circuit, both in our railway electrical control circuit of induction substation or other places, and also in locomotive control circuit. This is the normally closed and normally open contact as given, just like binary system, yes or no. So suppose in the safety relays in the locos, all the delay normally close contact is given on the DJ closing and opening circuit. If any safety relay energize, this DJ closing coil will de-energize and the DJ will trip. So this is the use of the loco, this normally close contact. All the safety relays close contact is given in the DJ's EFDJ and NTDJ coil. I have shown you already. And in traction distribution, I have already told, when DC supply is failed, it is very dangerous because the relay will not work. So the circuit breaker will not trip, because circuit breaker tripping through DC tripping coil and closing coil. If DC fails, it will not trip, and if any fault in OHE, there will be fire accident. So it is very important. So what we have done in the capacitor tripping device, we have provided a capacitor when DC supply is available, is close contact with the close contact of the relay. One of the relay it energized, is charged, fully charged. But when DC fails, the normally close contact will, make, because the relay has de-energized, the relay will release the contact and close contact will, make, because the relay has de-energized, the relay will release the contact and close contact will, the normally closed contact will make, and the DC positive will be extended to the DC trip coil of the circuit breaker, and circuit breaker will trip, and power supply will be switched off from our relay overhead system. This is the safety. This is the main health of a substation control circuit. So I have told you both the system normally close and normally. Try to understand it. This is the basic. I like to clear the base, because if your base is clear, you can build up a big building on it. So clear your base. Okay. Thank you, friends.